Okay, basically, we have two kind of different choices when you're working with a problem like this. One is to actually do it with the fractions, which I think is what you were talking about last night, and the other is to actually just clear out the fractions. I'm going to work with the fractions first, just to kind of show you how it would be done. Obviously, I'm sure you're familiar with the standard formula for quadratics, ax squared plus bx plus c, and of course the quadratic formula in general. So I won't go into that. If you need me to, let me know. So a is 1, b is negative 14 over 15, and c is negative 8/15. Okay. Now, anytime I'm working with fractions and the quadratic formula, something that's important to me is I want to work through the discriminant before I work through the entire formula. Basically, it means there's a lot less confusion later. In case you've never heard that word, the discriminant is this piece right here under the quadratic formula. B squared minus 4ac. Okay? And again, I'm just going to work through this before I bother working with the rest of the formula. So my b is negative 14/15. I'm squaring that, and then I'm subtracting 4 times our a times our c. Okay, so we're going to square it first. One of the most popular ways I have seen students have trouble with this problem is when they square a negative number, they don't make it positive. So be careful on that one. Anytime you square something that's negative, it's going to result in a positive. Negative 14 squared then is 196. 15 squared is 225. Okay? Other problem here, make sure you're paying attention to this negative and this negative becoming a positive. 4 times 8, of course, is 32 over 15. Now, we're doing this outside the discriminant, again, just to kind of relax the fractions a bit. As I'm sure you know here, this needs a common denominator, in this case 225 because it's 15 squared, which means this fraction needs an additional 15 both on the top and the bottom. Alright, I'm going to grab my calculator for the 32 times 15, that is 480. Okay. Now, again, I'm going to go to the trusty calculator and add this up. So the 480 plus the 196, and it does give me 676 over 225, and that's our discriminant. What that means is this entire fraction is under a square root. Now, the fun thing about fractions under square roots is if your fraction's under a square root, you can actually write this instead as a square root over a square root. This, we know, is 15, so now our bottom fraction's a 15. And now we've got to take the square root of 676. Obviously, you can break this down with perfect squares. One of my favorite tricks is always find out first whether or not it's a square root. I'm going to raise it to the 0.5 power. And it turns out this is a perfect square root, and it is 26. If you don't have a calculator, you're going to have to play around. Problem with this is it looks like 676. Since it's even, I would start and see if 4 goes into 676. 1, 6 times 4, 24. And that does give you 169, which, as you know, is a perfect square also. So then you could write this as the square root of 4 times the square root of 169. I'm sure you've done this already, which is 2 times 13, which will also get you to 26. But again, if you have a calculator, use it to your advantage. Okay, so now I know that this whole square root piece, because I put my square root in, winds up being 26/15, which means I can change my formula now to negative b plus or minus 26/15 over 2 times a. So the next thing, of course, we want to know is what is 2 times a? Well, 2 times a is just 2. So that's nice. B, of course, we're coming back over here. It is negative 14/15. We, of course, want to change its sign. We want the negative version of it. Right? Okay, well, negatives cancel a positive. We have 14/15 plus or minus 26/15 divided by 2. Okay, this is nested mathematics. Obviously, we're going to split this up into both the plus and the minus at this point. 14/15 plus 26/15, and then divided by 2. I don't like writing this whole thing over divided by 2. One of my favorite things to do instead is do it like this. That way I can find out that this is 40/15 times 1/2. And then, of course, properties of fractions let me reduce this to 20/15, which reduces by 5 to 4/3. You do the same thing with the subtraction. And I am running out of room. I apologize. I write too big. This is going to subtract to 8. Not 8/15, never mind. This is going to subtract to negative 12. Switch back to pen. Negative 12/15. That's still divided by 2. Ooh, it's Photoshop. I can scroll over. Okay, that's still divided by 2. So negative 12/15 times 1/2. Let's see, this reduces by 3. And then my 4 reduces by 2. So I get negative 2/5. Those are my two answers. Okay, as I said, that's a pretty crazy method to do it, but it will work. So if your teacher's requiring you work with fractions, basically that's how it goes. The only sticky situation, again, is when you get into these huge perfect squares, and then use your calculator or break it down. Okay, I'm going to do it the other way now.